Hello students, in this video we are going to now look into linear trend line, which is simple regression we are going to use between the dependent variable and an independent variable. So suppose y is our dependent variable and x is our independent variable, then we are trying to get an equation in this format: y equal to a plus bx, where a will be the x-intercept of the line when x will be equal to 0, and b will be the slope of the line. Right, now how to find out this? So there is a ready-made formula which can be used. Of course it can be derived, but right now for us it can be very easy for us to remember the formula for getting a and b. Just observe that the denominators for both the formula are same, which is n times, the n means number of observations, sigma of x square, so I will explain that, minus sigma x the whole square. This is the numerator, and in the denominator for a it is sigma y into sigma x square as the first term minus sigma y into sigma xy. So this ratio will give us a, which is our x-intercept, and b is given by n times sigma xy minus sigma x into sigma y. So this particular ratio will give us the b, which is nothing but a slope. So how to go about calculating this a and b and establishing this equation y equal to a plus bx? Assume that we have been given this periods x, which is 1 2 3 4 12 periods. If it is sometimes it will be given as a, say, year, like that. So you can just simply use, suppose this is what is given, right, the years. You can simply create one variable x as called as period and use 1 2 3 4 for that, and you need not use these values, because it will make your equations very the calculations very high size numbers will be there. So we will use these periods, and suppose the demand which is given to us is this for this particular period. So in the 2000 period 1 we have 36 37 maybe 1000 or whatever is the unit demand, and this is what it is. So we want to establish the equation between y and the period. So what we need to do, first we need to create two columns. First column is xy, which is multiplication of this and this xy, and also we need to create a column x square, which is the square of these x values. So we have created these columns, and then we will require the additions of all these four. Will require sigma x, will require sigma y, we will require sigma xy, and we will require sigma x square. So calculate the totals for all the four columns and then use these equations. So if you see sigma y, I think we have already, these equations are there, right? So you can clearly see that they have used these equations here, and you will get the values here, right? And right, so basically you can, right, so you will use sigma y here, then sigma x square will be this, then sigma y will be this again, and sigma xy will be this, and denominator is n is number of observations, so 12 here, sigma of x square this one. So the difference between sigma of x square and sigma x the whole square, you have to understand. Here sigma x the whole square is used, right? And for b it is sigma xy times n, minus sigma x into sigma y. So once you get this, you will get these values a and b, and then you will get the equation y equal to 35.21 times 1.72 times x, and for the next period, that is period 13, you can find out the forecast for this. So looks little bit a bigger example, but sometimes you will have to solve such examples in the exam, and many times this particular for the method is required in the next seasonal adjustment question, which we are going to do in the in this video only. We will continue and do that seasonal adjustment, or I will be making another video for seasonal adjustment. So this is how we use the linear trend, establish the linear trend, and compute the forecast, right? So if you just put these values for x into these equations, in these equations, you will start getting the forecast for these periods also, and the actual value and the forecast can give you the error, which we have learned in my previous video, where how to calculate the model accuracy or the various errors like MAD, MAPD, MSC, etc. So for that we will require this demand and the corresponding forecast values. Thank you.